I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast helps you understand the chemistry of your everyday life.
Okay, Jam, are you ready for what we're talking about today?
I'm so ready. I need some chemistry today in my life. So let's do it.
Well, you always have chemistry in your life, but you need a chemistry lesson in your life today.
Right. I need to be thinking about the chemistry. It's always around me, but you don't always have time to think about it. So it's like this is the time I want to open the floodgates for chemistry.
All right. Well, I'm going to open those floodgates because this topic is jam-packed with different chemistry ideas.
Oh, interesting.
Okay. We did a whole two-parter on Teflon.
Uh-huh.
And I've got to tell you that it really got under my skin. But I was looking for my alternative, and I remembered my brother-in-law, who pretty much exclusively uses cast iron pans. And I have a cast iron pan.
Yeah.
But it's one of the newer ones, not an old passed down one. And I had some trouble with it, and I kind of gave up using it.
Uh-huh.
And my roommate, my current roommates and my previous roommate had one of those cast iron grill pans, and those things are so hard to keep clean because of those grooves.
Yeah.
I could season my cast iron and make it real nice and easy to use, and I could never do hers. So I kind of got annoyed at cast iron and put my pans away and haven't looked at them in a while, but this inspired me. I was inspired.
Uh-huh.
So my new thing is cast iron pans. I'm all about them, and I did all of this research, and I'm in. I'm here for it.
Dude, nice.
So I'm going to share what I learned with you.
Oh, please do.
And then post a super cute picture of a cast iron pan that I restored.
Nice. You're bringing it back.
I'm bringing it back. I'm bringing them back. Okay.
There's definitely like a loyal cast iron subculture out there.
Oh, 100%. There's even a cast iron subreddit.
Oh, interesting.
Mm-hmm.
That makes sense. They found each other.
So I'm going to preface all this by saying it's hard to find a lot of scientific papers about this for whatever reason. A lot of the topics we come up with, I'm like, this is going to be so hard to find. In this case, there was a lot of popular science, but not a lot of endorsed science from scientific journals or whatever. So I was kind of hesitant to use some of the things that we found, but I relied heavily on a video from the American Chemical Society, Reactions.
Mm-hmm.
They have a series called Reactions where they investigate popular science. It's really fun. I relied on that video, and they referenced and endorsed a book called The Food Lab.
Mm-hmm.
It's a textbook of chemistry of cooking or science of cooking.
I have seen that book. I think our mutual friend Ryan has that.
That's correct. Our mutual friend Ryan does have that. And they have a section on cast iron in there, and we have the video of cast iron, and then I used a lot of my own understanding and knowledge to assimilate to give you the information I'm going to give you today.
Nice.
So just wanted to preface that.
Pumped because I think, like many people, I've always been a little overwhelmed by the idea of cast iron. It sounds really cool. Like the people who love it and use it make it seem like it is the best ever. And then, I mean, I've had a couple experiences with it where it's like, what do I do? It doesn't look right. Or like, it just doesn't seem like I can do the same things. Is it going to take me way longer? I just feel out of my element. And so I'm excited to learn a little more and hopefully maybe feel more confident and maybe go the way of our forefathers and go for some cast iron.
Well, after my recent experience with cast iron, cannot encourage you to do that enough.
Oh, nice.
So, first chemistry lesson regarding cast iron.
Okay.
What the heck is cast iron?
Yeah, what is it?
So, cast iron is a type of iron alloy. So, you get iron ore and you basically melt it down in, I think it's called a blast furnace. I learned this from a general chemistry textbook. And they sort of sort out based on, it seems like the density where the pure stuff sort of goes to the bottom. And they get the iron out from the bottom and can pour it into mold. So cast iron is an iron alloy. It's not pure iron. It's got some carbon and some other stuff in there.
Yeah.
And they pour that into a mold.
Okay.
So your cast iron is one piece of metal, a cast iron pan, which is nice because there's no like joints or anything like that. It's all one piece.
Right.
And also the fact that it's all one piece has something else that's valuable to it that we'll get to in the next part.
Okay.
So that's why it's, you know, got all the handle, all that's attached. It's all one piece. It can't get messed up. And actually, that's why the newer cast irons have that little orange peel texture to them. Old cast irons are really smooth because when they took them out of the mold, they used to polish them down.
Oh.
And they don't do that anymore.
It's better not to, or we'll get to that later, or?
Well, I think it's
Unconfirmed?
just a preference thing, but it does seem like having that a little bit of smoother surface makes it a little bit easier to form the nonstick layer. But I don't know for sure. It just seems like it forms a more even coating over it.
Yeah.
That's my anecdotal evidence.
Okay.
We don't have any fact based on that. Just that they used to polish them down and they don't anymore.
So wait, so is cast, did you say like why it's called cast? Is it because it's all one piece?
It's like wrought iron is worked and cast iron is molded.
Got
it's
it.
just cast as one piece. So that's your first chemistry lesson.
Okay.
Your first chemistry lesson here is the way that the iron is even made is a process of heating and separating out metals. It has an iron alloy. All of that process is chemistry.
So I'm trying to say that back so that I repeat back each kind of mini lesson as we go, and also maybe correct any misunderstandings as we go before we get to the end and I potentially misunderstand 3 different lessons.
Perfect. That sounds great.
Okay, so cast iron is an iron alloy, and I guess one of the importances of that is what you said, they melt it down and then like impurities and stuff like that float to the top.
Yes, that's what it seemed like from what I read. They melt down iron ore, and it seems like there's a lot of impurities at the top that almost form a protective layer from oxidizing. And then it seemed like there was less and less impurities as you went down, and then they separate out the pure iron from the rest of it.
Got it. So take the best stuff out of that.
Yeah, it reminded me of almost like a pitcher, you know, where you have the spigot at the bottom. That was kind of what the furnace looked like. The pure iron came out at the bottom.
Oh, nice. That's a good move. I see what you're saying. Yeah. I used to do that with kombucha because the SCOBY hangs out at the top. So if you have a spigot, then you can do that. So they take the best stuff, the impurities float to the top, and they try to get the best stuff from the bottom, which is the most pure in some way and probably the strongest or something.
Well, it's the purest iron, but in this case, they don't use pure molten iron. They do have some impurities in there. That's why it's an alloy.
Got it. Okay. Alloy means it's not just one thing.
Right.
Got it. Okay. And then they mold that into one entire piece, which probably made tons of sense and wasn't that like novel at the time. But for us now, all of our pots and pans, if they're not cast iron, are like multiple pieces, like some things screwed onto each other or whatever. And so in this case, it's just molded, cast into one piece, handle and all. And
that's right.
That's cast iron?
Yep. So cast iron is a purified type of iron ore. It's not perfectly pure. That's why it's an alloy. And all that process is a chemical refining process. It's chemistry.
Is them saying that it's not like it's an alloy, it's not perfectly pure, is it just because that's like technically true, but they are trying to purify it as much as makes sense with that process?
I think you can get pure iron. I just think cast iron pans maybe are as effective with the alloy. I don't know. I think the alloy is desirable. I don't know a lot about metal. I don't know a lot about the chemistry behind metals or metallurgy, why cast iron is better. And I did find an article about the metallurgy of cast iron, but I couldn't access it, which was very frustrating. So I think that actually the metal alloy that they use for cast iron is what they desire. They could purify it down further, but they stop.
Okay.
is my understanding.
Okay.
Okay. So that's your first lesson.
Sweet. I like it.
Purification and formation. Second lesson. This is a review lesson. Do you remember when we talked about specific heat and heat capacity?
Yes. Oh,
Yes.
man. This is an old one, too, isn't it?
It's an old one. We talked about it on the What's Up with Foil episode.
Uh-huh.
And we talked about it on the why are water and sand different temperatures at the beach.
Right. Okay, yes. I remember them, and I remember them being slightly different from each other, and I'm worried that I'm going to get the definitions wrong.
Okay, I'll do a quick review for you.
Okay.
Okay, so specific heat is the amount of heat it requires to raise 1 gram of one substance by 1 degree Celsius.
Okay. I should have gone with it, man. I would have gotten at least that one right. Dang.
I knew you could do it, but just in case, I wanted to give you an out.
Thank you. I appreciate that.
And this heat capacity is the amount of heat it takes to raise one object by 1 degree Celsius.
Right.
So specific heat is if you had 1 gram of aluminum and 1 gram of cast iron, and you were trying to raise each of those by 1 degree Celsius, how much heat would it take?
Okay.
Heat capacity is if you had an aluminum pan and a cast iron pan, which have very different masses,
Mm-hmm.
and you're trying to raise each of those by 1 degree Celsius.
Got it.
Okay, so that's my review of specific heat and heat capacity. Now, what makes cast iron pans good at cooking is actually that they take a long time to heat up and they take a long time to lose heat. They hold onto your heat well.
Mm-hmm.
So you have to preheat them, but once they're preheated, they can hold onto that heat well.
Mm-hmm.
Now, you might think that the reason for that is they have a higher specific heat than aluminum, but that's actually not true. They have a lower specific heat than aluminum. Cast iron has a lower specific heat than aluminum.
So if you took the gram for gram comparison, that would be obvious.
If you took the gram for gram comparison, your cast iron would heat up faster and lose heat faster than your aluminum,
Huh.
which is not desirable for cooking.
Right.
But if you took a big, heavy cast iron pan, you have to heat up all of that mass.
Mm-hmm.
And that takes longer to heat up than a light, easy aluminum pan. And because of all of that mass that's holding onto the heat, it's going to lose heat more slowly.
This is like such a great example at the differences between those two things. It's like, okay, this one's got a lower specific heat, but it has a much higher heat capacity or whatever. That's
exactly right.
That's a really cool illustration. Dang.
And we went in depth into the heat capacity on the foil episode. That was when we talked about why mass makes a difference in heat capacity.
Yeah.
But ultimately, more stuff means it's going to take longer to heat up, regardless of the specific heat.
Right.
So that's your mini lesson 2.
Okay. So if you compare a cast iron pan to did you say aluminum? Is that what our other pans are made out of most of the time?
An aluminum pan or a stainless steel pan or a Teflon pan. I mean, I think you could have lots of different kinds of pans. I'm not a pan expert. I've only studied cast iron and Teflon at this point.
Okay. So basically, if you just had 1 gram of each of those substances on their own, the cast iron would heat up more quickly than it would take less heat to heat it up by 1 degree than it would the aluminum or stainless steel. But
right.
in actual daily life, because we have them in pan form, the mass of cast iron is so much more, which, I mean, I haven't even used them very much, but I know that to be true. It's just you gotta really, really be ready for that weight. Because it has so much more mass, it does take a lot longer to heat up. Its capacity, it takes more heat for it to heat up than it would, say, if you had an aluminum or stainless steel pan on the very same or next door burner on the same setting. but then it doesn't lose the heat as fast because it has such a greater mass. And if you've got the time for it to preheat, then it's obviously going to be better because it's going to retain that heat better. Is that right?
That's right. Mm-hmm. So now we know how cast iron pans are made, what the heck they are, and the chemistry behind that.
Mm-hmm.
And now we know why they're good for cooking in terms of heat retention.
Mm-hmm.
Okay. So your third mini lesson is about how it gets this non-stickiness.
Oh.
And this non-stickiness is what I want because I hate cleaning stainless steel pans. I hate it. My mom had those pans. I hated it my whole life. I don't feel like we should have to do it. It makes me miserable. So this is what attracted me to cast iron pans in the first place. Now, I worked very hard to find as much information as I could about this, but I'm going to give you the basics and then a super cool fun fact.
Okay.
So essentially what happens when you have a cast iron pan, you may have heard of this thing called seasoning.
Yes, I have. I was going to ask about that. If that's not what this was, then I was going to ask. So that's perfect.
Well, what this seasoning really refers to is essentially this nonstick layer. And the nonstick layer is a polymer.
Oh, ho, ho.
And the polymer is the same thing that makes Teflon not sticky.
Right.
It's the big molecule made up of a bunch of small molecules. But in this case, instead of a polymer being formed as an indestructible, quote unquote, indestructible chemical somewhere in a lab, you use oil to coat the cast iron pan, and then you bake it at a high enough temperature that it will polymerize. The oil itself forms the polymer all around the pan. And that polymer forms thin and hard. And it's stuck on your pan really well, but it will not interact with other things, just like we talked about in the Teflon episode.
Oh, nice.
It's almost as if you have a layer of self-created Teflon, a self-created plastic that you put over this pan. So it has those same convenient properties, but it isn't formed with harsh chemicals. It's just formed with vegetable oil.
Nice.
And it happens when it reacts with oxygen, and the cast iron and the fat make a polymer.
Wow.
Now, what's interesting, I was trying really hard to figure out what molecules in particular make this and all these things. And there was wisdom about, okay, well, there's a paper that basically went into form these different kinds of polymers and hardness, and flaxseed oil and canola oil form better. They're unsaturated fats. They form better polymers than, say, like bacon fat or lard. Better, harder polymers that are going to give you a longer lasting coating. There's all kinds of stuff like that. But then I found one paper that talked about how vegetable oil is almost the new frontier for making polymers and plastics and consumables because it's non-toxic and there's so many different types of oils that you can make polymers with. And so it just investigated all these different properties, the hardness of all the polymers that you could make with vegetable oil.
Holy.
It was so interesting to read about.
Dude, that's crazy. And it seems to me like it's just the most like average household oil. I mean, we've always had access to it in our lifetime. And so it kind of just seems like not that cool in a lot of ways, you know?
Well, and they did it with different types of vegetable oils. So they did sesame oil, castor oil, linseed oil. They actually did fish oil, olive oil, all kinds of they tested all these oils. It was amazing.
Wow.
I thought it was so interesting. So that's a fun application of your cast iron polymer somewhere else, that they're investigating the usage of those, making new polymer materials from vegetable oils that you would have in your kitchen.
Wow. Dude, that's crazy. We're just making our own version of the same thing that was made in some lab or whatever, but we can do it with just some household stuff, which is...
And people have been doing it forever.
Yeah.
Probably since before there was polymer chemistry at all.
Yeah. They just figured it out. Like, hey, this is pretty nice. It's not nearly as sticky.
Mm-hmm.
Let's do this more, whatever it is.
So that's your third mini lesson.
Okay. So, just like how Teflon is a polymer, which is a molecule made up of molecules, a lot of repeating molecules that create basically a layer, force field kind of thing, if you will, that won't interact with things that aren't itself.
Mm-hmm.
And so you can throw an egg on there or a steak or whatever, and it gets to experience the heat without starting to like stick and get all like glued together and stuff, because the polymer is like, we only care about each other. And somehow, because oil interacts with you said the oxygen it's in iron?
It's a reaction of oxygen and iron.
Okay.
And the oil with itself.
Got it.
To make the polymer.
It makes a polymer, and the heat that you put it through.
Right.
Makes a polymer of our own on these cast iron pans that can have a similar nonstick property without some of the alleged downsides of Teflon, which is like way awesome.
Exactly.
Dude, that is awesome. That's way cool. I don't know why they call it seasoning. It just doesn't really, that's not what I thought that meant. I thought it meant like,
I think,
cook a lot of stuff on it, and then the pan starts to have a seasoning, like a taste. And I was like, I don't know if I want that. I want like the next thing I make to taste a little like the last thing.
yeah, I think they call it that because if you have an old cast iron, like my brother-in-law has a cast iron, there's something about cooking on it that does give it kind of a different flavor almost. But I don't know why they call the hard layer seasoning. I assume that name came from before they knew anything about what the layer was.
And I guess it could mean too, like when you say like, I'm a seasoned whatever professional, it kind of also just means that like you've been through many seasons, like you have a lot of experience, not really that you taste a certain way or whatever.
Yeah.
So I just misinterpreted it.
They taste a certain way. That's funny. And also cast iron is very porous. So if you didn't have that seasoning, it would be very easy to get your food literally bonded to the cast iron.
Oh, yikes.
A reaction could happen between the iron and your food, and it would be deep in those pores. So that polymer protects it from that. But there's more.
Whoa.
I took a polymer chemistry class in college, and the wisdom in that polymer chemistry class as it related to polymers that were used in paints, nail polish, that kind of thing, is always that your most effective layers to build up thickness is going to be lots of small, thin layers. So that's why you put on one coat of paint and let it totally dry, and then put a second coat on.
Right.
And same thing for girls. Or guys, I guess, people who consistently paint their nails. You know, when you were probably a kid, you tried to like load that nail polish on and it gets sticky and awful and is not effective. But if you put one thin layer and let it dry and then put another thin layer, it keeps the hardness and the thickness.
Ah, interesting.
So you can do that same thing in cast iron. You can put a very thin layer of oil, bake it, and then put another very thin layer of oil and bake it. And you can build up those layers on top of each other so you have a thicker and harder, more effective layer of seasoning.
No way. So how many is like a good amount where it starts to have a really like solid nonstick property to it?
I think it's just personal preference. I do mine just once because I'm lazy or have traditionally. And this book said to do it. The Food Lab book said to do it 3 times.
Okay.
But it said until it's basically as dark as you want. So you can kind of see that as it gets blacker, it's got more of those levels built up.
Nice. Okay. Gotcha.
So that's personal preference. One layer should do you good, but it just may not last as long.
Okay.
It really is conventional wisdom, and I think makes the most sense to season the whole pan at once because it's all one piece of metal that was cast, like we talked about. So if you put the polymer coating all over, the whole pan is protected from water, which will rust iron, and it's protected from food getting on it, and it doesn't have as many endpoints to where that polymer coating is maybe not there and stuff can get in and degrade your pan. So it's best to season the whole thing at once. If you just did maybe the inside, the outside isn't going to be protected. So half of that piece of metal isn't protected.
Right. Gotcha.
You can corrode from the outside or rust from the outside or whatever.
Yeah.
So it protects the whole entire pan.
Okay. Gotcha.
Over time, that polymer coating will get maybe chipped away or have some holes in it. So at the end of every use, they recommend you put a light coating of oil and heat it to the smoking point to basically form a protective layer over your polymer coating.
Dang. Every time?
Every time. It's really not that bad.
Okay. How long does it take? Oh, smoking point, like you mean do that in the oven or do that on the stove?
Do that on the stove.
Got it. Okay.
So you get your initial seasoning on where you put a thin coat of oil and then you bake it. And that gets a nice polymer layer over everything. Mm-hmm. And then you've got that base polymer layer, and not much can really impact that. It's hard. There's some wisdom about not washing it with soap, which we'll talk about that, but it's a pretty hard layer. Mm-hmm. But just to protect it from impact, getting chipped, things like that will eat away at the polymer, which is not a ton of stuff. After you cook with it, take your pan over to the sink, scrape off any old food particles, come back to the stove, dry it off, and then I use a little bit of oil and spread it around with a paper towel or a rag cloth and just let it go on low heat for like 5-10 minutes until you get a light smoke and then just turn it off.
Wow.
It, to me, is almost as easy as cooking with a nonstick pan. You just have to heat it up afterwards is the only difference.
Yeah, that seems not quite as bad. I was thinking it was like a whole, like, wipe the whole thing down again, put it in the oven for like an hour or something like that. I just thought it was going to be like, oh my gosh, who's got time for that other than like chefs, you know?
No, not at all. You do that one time or a series of times in one day or whatever. Mm-hmm. And then you can go back and just do the oil coating as a protective layer at the end.
Dude, sweet. That seems not quite so bad.
It is not quite so bad at all.
I think I'm down.
I'm so excited. I convinced you and hopefully everyone else.
Yeah, I've got a few people to talk to about like any pots and pans decisions in my home. So it's not just up to me, but we've got a pretty strong case. And I think at least one or two other people in my house listen to this. So I might just have to wait and let them hear it. And then they'll be convinced too. I don't have to do any work.
It really is pretty easy. I will say the rule I've always heard is that you shouldn't wash it with soap because it'll mess up the seasoning. Scientifically, that's not super logical. Polymers are not affected by soap and water. But I think the reason that people say not to use soap on your cast iron pan is because oil is good on the cast iron pan. It protects that porous surface. And all you have to do is get it up to that smoke point and it will polymerize and protect your pan.
You're just taking that oil off that it kind of wants. It's not a polymer yet. That new oil is not a polymer yet, but you're taking off something that you actually kind of do want on there.
Exactly.
Got it. Okay.
So I think that is why it's not really recommended to use soap consistently because it's not bad to have oil on there and you can put it up to that smoking point. It'll polymerize and it won't turn rancid. It basically protects any holes that are maybe forming in your seasoning.
Got it. Okay.
If you do want to restore a cast iron pan, I had to do that. We had a grill pan that literally had black crud built up between the grills.
Ugh.
It was very icky.
Who cooked some crud for dinner?
I'm not at liberty to say.
Oh, okay.
But I have always struggled with these pans, and then I discovered that Lodge Cast Iron makes a grill pan scraper that is incredible. They also make a regular cast iron pan scraper. And I highly recommend there's a 2-pack for like $3 where you can get the grill pan scraper and the regular pan scraper, and they're amazing.
Nice.
You can just take your food, scrape it off, do a quick rinse with water, heat it up, add some oil, done. No problem.
Nice.
So I took that scraper, scraped all the crud, and I went ahead and actually sanded down the top layer of both of my cast irons.
Whoa.
Because they come with a pre-seasoning that I don't think is very impressive, and I don't love that orange peel texture.
Mm-hmm.
So I sanded it down a little bit. You don't have to. And then I used steel wool and soap to get any weird leftover crap that I didn't want that was unpolymerized oil off. And you can also, I think, the abrasive nature of the steel wool kind of knocks some of the old polymer off. Like it can chip away at it if there's already holes. That's my understanding. I don't know for a fact.
Okay.
So you basically get it down to as close to the original layer of the iron as you can that doesn't have permanent polymer on it. Knock it all back and put the new layer of polymer on. Fresh oil in. So it sounds like a process. It only took me like 2 hours to clean both these pans, and one of them looks brand new again.
Dude, nice.
So I had a fun time restoring it. It is very enjoyable to me, and I've been using it for the past like week or so, and it has been fun.
Nice.
So I highly recommend cast iron pans.
Dude, you go. Restored one, brought it back from the brink kind of thing.
Well, and that's the thing is they can actually take a lot. People are like, oh no, cast iron. You're going to ruin it. You touched it with soap. But really, it's just a hunk of metal. So if you mess it up, you just take off whatever you messed up and start fresh.
Right.
And very forgiving. And once you get that nice seasoning layer on and you learn how to maintain it, just do the oil coating at the end every time, you're really in great shape with those cast iron pans.
Dude, yeah. And it's like there's plenty of mass to go around. I mean, like you do have to, if some get chipped away or you have to do some sanding like you did or something like that, there's a lot more mass to deal with there than there is for some of the pans we're used to using. So it can stand to lose a little bit if you need to, if it's old and from our founding fathers or something like that.
Yeah, and older cast iron pans are generally better. It gets better with age and time.
Nice. That's crazy, dude.
I know, it is crazy. It's so fun. I was so fascinated to find that polymer that builds up on there is also polymers that they're trying to use to make other materials, you know? It was super interesting.
Yeah. That's crazy.
So that's my bid for you guys to use the pan that's just chemistry centric. And like I said, there's some things that I had to conjecture and use my best knowledge about polymers, soap, oil, water, and all of that to figure out why it would do what it did. But that is what I've got for you today.
Dude, awesome. I like it. And full disclosure, this episode is sponsored by Cast Iron for America.
Let me go look it up, see if that's real. Not real.
Nice. Okay, sweet.
Okay. So that's all I've got for you today. Chemistry of cast iron.
I like it, dude. I'm hungry now. I'm going to have to start looking into some cast iron for sure. Is it the time where we talk about our weeks?
I think it is.
Awesome.
Well, I'm going to go ahead and cheat and say that my happy thing this week is the pan that I restored. I mean, the one is fine, but that grill pan, the biggest mistake I've ever made was not taking it before a picture.
Dang.
I'm going to post a picture of it online, and I just want you guys to imagine it being rusted, having black whatever built up in between every single one of the grills. Just like, it was basically flat because it had so much crap built up in between them.
Yeah.
It was awful. So I'm going to post a picture of how beautiful it looks now. And that's my happy thing.
Maybe
I'm so satisfied.
Maybe you could find, like, just search around and see if you can find an analog of, like, how bad it was. Because you have the image in your head. If you just search for, like, surely there's, like bad cast iron or old cast iron photos if you look.
I'm sure, yeah.
So maybe you could find one like that and it just put like a little text like reenactment or whatever, like they do for documentaries and stuff. Because it'll probably be obvious that it's not the same pan, but that way we can get an idea of how bad it was. Because I'd love to like just kind of know and have a visual context for how bad it was.
Okay, I'm gonna find it. So really, this whole episode was in dedication to my happy thing this week.
Nice, that's great. You got like so much time. That means I get to have about 20 minutes to share about mine, right?
Sure.
JK, okay, this is kind of boring, but I thought of it, I think, partly because you're talking about, one, I'm in the room that's going to be the nursery for our kiddo. And also you're talking
I'm so excited for kiddo's arrival.
I know, me too. And also you're talking about projects and stuff like that. So one of the back burner projects I've had is working on this room. And it wasn't exactly this week, but not too long ago, I swapped out the electrical stuff in here. There's only one outlet and one light switch. And they were old and they were kind of like, I'm not crazy old, but like they're like a cream color that just doesn't look very good. And we really wanted to put a dimmer on the light switch. And so I changed out the outlet for one that looks more like modern and is like a more pure white and like more of a rectangle look to it rather than like each outlet thing being round. It's a whole rectangle. Looks better. And then changed out the light switch for a dimmer and got one that you can kind of adjust how dim it does get also. Like not just you pull the fader down, but in the installation stuff, you can set how low does the dimmest part go.
Oh, wow.
Yeah. So pretty awesome. Obviously that has a lot of use for a room where a little kid's going to be sleeping. So that was just like a really rewarding project and I didn't electrocute myself or anything. And it was like, just to see that. I mean, I know people do it probably like, there's some people who do that tons of times a day or whatever, or they've done this for rooms that have way more electricity, but it was like, nice, this works. And I didn't die. And then fading it, down, dimming it was just like so fulfilling. So that was my thing.
That sounds really exciting. I'm proud of you. It's so nice when you can do something on your own.
Yeah, it really is. And I've had a failed electrical house thing before where I couldn't fix the problem. It wasn't like I messed it up, but it was just that what I was trying to do, I couldn't fix the problem. And so this was one where I was like, nice. What I set out to do, I did, and it worked. And I didn't have to call an electrician. So
that's exciting. Congratulations. Good job. Way to not electrocute yourself.
Thank you. I'm also glad that I didn't. Probably a little bit more than you are.
I mean, without you, we couldn't do this podcast. So I'm
That's
pretty
true.
thankful when you're alive and well.
Right. I just mean like, I think sometimes the person might be the most thankful that didn't get electrocuted.
Maybe. I guess we have no way of knowing.
There's no way to know. Yeah, we can't ask. Yeah.
All right. Well, thanks for coming and hearing me talk all about how enamored I am with cast iron pans and the chemistry behind them.
Thanks for teaching me.
It was a dream. And thanks to all of you listeners for also coming and listening and learning. And I hope you have been convinced. If you have, send me pictures of your cast iron pans because that'll be fun. We can post them on Instagram or Twitter if you want to tag us. I love cast iron pans. So
that's a great idea. Yeah, that'd be sweet to see. Melissa and I have a lot of ideas for topics of chemistry in everyday life, but we want to hear from you. Share your curiosity with us. What have you wondered about? If it's a chemistry related thing, ask us. We'd love to explore that with you. Send us those questions or ideas on Gmail, Twitter, Instagram, Facebook at Chem for Your Life. That's Chem, F-O-R, Your Life, to share thoughts and ideas. If you enjoy this podcast, you can subscribe on your favorite podcast app. And if you really like it, you can write a review on Apple Podcasts. That helps us be able to share chemistry with even more people. If you'd like to help us keep our show going and contribute to cover the costs of making it, go to ko-fi.com/chemforyourlife and donate the cost of a cup of coffee.
This episode of Chemistry for Your Life was created by Melissa Collini and Jan Robinson. References for this episode can be found in our show notes or on our website. Jan Robinson is our producer, and we'd like to give a special thanks to In Newell and A. Collini, who reviewed this episode.